Welcome, chemistry students, back for another fine lesson of week 9A. We're going to go over the law of conservation of mass in this lesson, where we see that the mass of the reactants is equal to the mass of the products. Okay, the first thing that you're going to need to do is you're going to need to click this link where it says periodic table and polyatomic ion list. And you already have a printed copy of this, but this may make things a little bit easier for you to do this assignment. So please just click in on that. And then the next thing is you are going to need a calculator. So click on that calculator link. And so now you can easily go back and forth between your calculator, your periodic table, and your lesson. All right, and in this example problem, I am going to be working on problems numbers 10 through 14. And this may or may not be available to you at a later time. My intention is to delete this. So if you want to go ahead and write this on a sheet of paper, you can do that. Okay, so what are we doing? In question number 10, I am asked to calculate the molar mass for calcium fluoride. Okay, and in the show your work section, I need to show the cross technique and the molar mass calculation. So I'm only really going to use this cross technique if the compound is ionic. And you will note that the compound is ionic if the formula does not have prefixes or is not a diatomic molecule. And if you don't remember your diatomic molecules, you probably need to make sure you go back a couple lessons and find your diatomic molecules. Okay, so we are to be looking at calcium fluoride. Calcium fluoride does not have the prefixes mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca in its name. And therefore, we can say that it is ionic. And if it is ionic, we have to look at the charge of the ions that make it up. And so let's make sure that we do that. So we have calcium and fluoride. So we're going to go to our periodic table, and we're going to find calcium, and it's right here, number 20. And calcium as an ion has a +2 charge. And so you should have these charges written above your periodic table, all right, for each group. So calcium has a +2 charge. So we're going to go back to our assignment, and we are going to simply write in calcium, and we're going to say that it has a +2 charge. And then secondly, we're going to find fluoride. So fluoride is fluorine as an ion, and fluorine as an ion is a -1 charge. All right, so fluoride has a -1 charge. All right, it has a -1 charge. The next thing that you ask yourself is, do the sum of the charges equal 0? Do they? No. And the answer is no, they do not equal 0. And so you have to use the cross technique. And so you see that we're going to put a 2 down here, not a +2, but just a 2. And we're going to put a 1 down here, not a -1, but just a 1. And what this says is that we have Ca, just 1, and then F2. Now, you don't have to show this part in your work, but I just want you to see what this actually means. It means calcium with a 2+ charge and 2 fluoride ions, each with a -1 charge. And if you added 2 plus -1 plus -1, you would get a total charge of 0. And that's what this cross technique does for you. Okay, so the next thing that you're going to do is calculate the molar mass of this compound. All right, so in order to do that, you already have your written formula. And so you're just going to identify the elements in your written formula. And they are calcium, Ca, and there is also fluoride. Now, I have 3 spaces here, but we only need 2. So you don't need this one. All right, and that's okay. You won't have more spaces than you need, but you may not use all the spaces available. So then your next question is, how many calcium and how many fluoride? So that's the number. So you're looking at your formula for this. So how many calcium do we have here? That's right, 1. And then how many fluorine do we have, or fluoride? That's right, 2. What is the next step that you think we're going to do? That's right, we're going to multiply. So we're going to multiply by our molar mass. So we got to find the molar mass. So where do we find the molar mass of our compound or of our element? So we're going to go to our periodic table. And you may remember in a previous lesson that we spoke about when the atomic mass is expressed as grams, that is the mass of 1 mole of atoms, or that is the mass of 6.02 times 10 to the 23rd atoms. Okay, and so we have to see, okay, I'm sorry, I had a pause there. But what I was saying is when you have the atomic mass expressed in grams, that is the mass of 1 mole of that element, 1 mole of atoms, or 6.02 times 10 to the 23rd atoms of that element. So for calcium, the molar mass or the mass of 1 mole is 40.078 grams. So we're going to plug that in, 40.078 grams. And for fluorine, that is going to be 18.998 grams. So we would say 18.998 grams. And so all we have to do now is multiply 1 times 40.078, and that is 40.078 grams. And then 2 times 18.998. I'll go to my calculator, and I'll say 2 times 18.998, and that gives me 37.996. And I'll plug that in, 37.996. I want you all to think I have a negative sign there. Okay. Now, what am I going to do with those two values? That's right, I'm going to add. So I'm going to add those two values. So 40.078 plus 37.996, and I end up with 78.04 grams. 78.04 grams. Okay, I think that's what I said there. Oh, 0.74. So let me change it. 0.74 grams. All right, and then all I would do is plug that in over here, 78.074, and make sure you put your grams as your unit. And that's all you're doing for calculating molar mass. So let's go to the next one. It says calculate the molar mass for molecular chlorine. Okay, so we're going to do that. And so if the compound is ionic, show the cross technique. If the compound is molecular, write the prefix with the meaning under the symbol. In this case, we have chlorine. And molecular chlorine is actually, chlorine is a diatomic. So what you can write here is diatomic. And so the formula for chlorine is Cl2. There's nothing to show because chlorine is a diatomic. And so what elements do I have in chlorine? Does anyone tell me? That's right, chlorine. So, and we only have chlorine. So we're not going to need these other two sections here. And so how many chlorine do we have in Cl2? Yes, 2. And so we have to go find the molar mass of chlorine. And we go over here and we see that it's 35.453. So we'll plug that in, 35.453 grams. Now we simply are going to multiply those two values. And so we're going to say 2 times 35.453, and we get 70.906. 70.906 grams. And actually, I need to put this here, 70.906 grams. Of course, we're not adding it to anything. We have nothing else to add, so it's okay that it goes there. So we type in our answer, and there you go. All right, looky there. Too easy. Now we go to the next one, and it says we are calculating the molar mass for calcium chloride. So calcium chloride, you should know, is Ca. All right, we've looked at Ca earlier, calcium, and it had a +2 charge, or we can say a +2 charge. And then we need to know chloride. Now, this is not molecular when it's in a formula. So chloride is Cl, and it has a -1 charge. Cl, -1 charge. Do the sum of the charges equal 0? No. So we do the switch, 2, 1, and we end up with CaCl2. So all we have to do is write in our symbols. We have calcium, we have chloride. We're not going to use this. And so now the number of calcium is 1. The number of chloride is 2. We go to our periodic table. We find the mass of calcium, 40.078 grams. We go to chlorine. We find the mass. It is 35.453 grams. And now you simply multiply. So 1 times 40.078 is 40.078 grams. And 2 times 35.453, believe it or not, you just did that calculation just a second ago, is 70.906. Now we just, and grams. And now we just add those two values. So I have 70.906 plus 40.078. All right, and I definitely have a problem here. So let me change that. 70.906 plus 40.078. There we go. And we get 110.984. 110.984 grams. And so we can plug that in. 110. My keyboard is not working right now. So you would just type it in right there, and hopefully that would work out. Okay, so we'll move on to the next part, and we'll go to the last one, which is fluorine. And fluorine is also one of our diatomics. So it is diatomic. So you can just write diatomic, and you will know that fluorine is F2. Di meaning two atom molecule. It's only made up of fluorine. So you're not going to need these two sections. You're only going to need one because all you have is fluorine. You have 2 of them. What's the molar mass of fluorine? It is 18.998. And now you just simply plug that in, and it's, you see 2 times 18.998 is 37.996. 37.996. And so 37.996. I don't know if my keyboard's going to work now. 30, evidently not. Maybe my battery's dead on it. 37, there it goes, 0.996 grams. All right. And we're done with that. Okay, so on this last part, and this will mimic numbers 5 and number 10, is you're going to rewrite your these formulas that you just wrote into an equation. So if you notice, we have calcium fluoride, and that we have calcium fluoride up here. And you notice that we have chlorine, and that we have chlorine up here. And that we have calcium chloride, and that we have calcium chloride right here. And that we have fluorine, and we have fluorine right here. So we already have the formulas made. Go back and refer to them. So for calcium fluoride, we said that the formula was, and make sure you leave yourself some room for coefficients because you are going to have to balance. So it was CaF2, and then and chlorine, and we said chlorine was one of those diatomics, and the formula was Cl2. And then it says reacts to produce, so we put an arrow. And then we said calcium chloride, CaCl2. And then it says and fluorine. And fluorine, we said, was one of those diatomics. Now we have to balance our equation. So we're going to list everything that we have. We have calcium, we have fluorine, and we have chlorine. So let's balance those. So we have 1 calcium here, 2 fluorine, and 2 chlorine. On the product side, we have 1 calcium, we have 2 chlorine, and 2 fluorine. So what do you notice? No one wants to tell me? I just lulled you to sleep. Okay, so it's 1, 1, 1, 1. It's already balanced. All right, so that was very nice. So the next thing you're going to do is you're simply going to list your compounds. So in the reactant side, that's before the arrow, that's on this side, and this is my product side, I have calcium fluoride, so I have CaF2, and I also have Cl2. What are my coefficients? 1 and 1. All right, so that made that easy. And then what is my molar mass of calcium fluoride? Well, I don't want to calculate that again because I already did. So I go up here and to a previous problem, and I go to my answer, and we said it was 78.074. So we're going to use that, 78.074. And we're going to multiply that times 1, which is 78.074 grams. And then we're going to go to chlorine, Cl2. And we don't know what our molar mass was for that. So we're going to go back to our previous answer, and we're going to find chlorine. And we said it was 70.906. So we're going to go there, and we're going to plug that in, 70.906 grams, 70.906 grams. And then we are going to simply add. So we're going to go to our calculator, and we're going to say 70.906 plus 78.074, and we get 148.98 grams. 148 point, make sure I'm not saying this wrong, 0.98 grams. All right, and now we're going to do the same thing for the products. What compounds do I have in the products? I have calcium chloride, and I also have F2, fluorine. What are my coefficients? 1 and 1. And then I got to find the molar mass of these. I already have those in a previous problem. So calcium chloride, wasn't able to type it in, but we said it was 110.984. 110.984. So we'll go back and we'll say 110.984 grams. And so 1 times 110.984 is 110.984 grams. And then for F2, we're going to go find that. And we said that it was 37.996 grams. So we're going to go back in there and say 37.996 grams, which multiplied by 1 is 37.996 grams. And so we'll add these two things together, 110.984 plus 37.996. And what we get is 148.98. So what we get is 148.98 grams. What do you notice about that? What is oddly strange? Well, you should notice that the mass of the reactants is equal to the mass of the products. And this is consistent with the law of conservation of mass. So when we run a reaction, the reactants don't produce more or less. It produces the exact same mass with the same number of atoms. If you notice in our balanced equation, we have the same number of calcium on the reactant and product side, the same number of fluorine on the reactant and product side, and the same number of chlorine on the reactant and product side. And therefore, we have the same mass, even though they are rearranged. So how do you put in your answer? I got an example response right here, but you're going to put in the mass of your reactant, which is 148.98 grams, and then you're going to say colon 148.98 grams. And so that's showing you both your reactant mass and your product mass. And that is all you have to do there. So that it gives you the whole scope of how to do that assignment. I hope you enjoyed. Please subscribe to my page, like and subscribe to my page. I'm here if you need me. And thank you for watching.